Hey there, Charger fam. This is Mrs. Boyd. Today we're talking about inequalities in two variables. It's all about graphing with two little bonuses. You can totally do it. Here we go. When graphing an inequality in two variables on the coordinate plane, we follow the same procedures as graphing an equation with two exceptions. The line can be solid or dashed, and we need to shade a region of the graph. So let's get rid of those words and do some graphing so we can see what this looks like. We're going to graph y less than x and y greater than x. If we have a less than or a greater than on a number line, it's an open circle. Trust me, that says open circle. This pen is hard. All right. So on a coordinate grid where we have two variables, that open circle translates into a dashed line. So both less than and greater than are going to be graphed with a dashed line. Let's see. We do graph this line, y less than x. We can imagine it's y equals x. So that way when x is 0, y is 0. When x is 1, y is 1. When x is -1, y is -1. All right? This is a dashed line. So far, it's exactly like graphing the equation, except for we have this funky dashed line. Last funky part. If our sign is less than, we shade below. So if this is our line, we're going to shade below it. So lay a pencil here on this line and drag it down. So we will shade below the line. With dashed lines, we don't include points that are along the line in solutions. All right, as you'll see, if we circle the solution, -3, +2. So that's with 3 left, 2 up, not a solution. It's in the white space, doesn't consider that a solution. 0, 0, it's along the line. It's a dashed line. That means any point along this line is not included in the solution. So that's also not a solution. And then we have 2, 1, 2 right, 1 up. This is in our shaded area. So this 2, 1 is a solution. All right. So far, so good. If we have y is greater than x, again, we're going to graph this same y equals x line. Something like that. But this time, our inequality is greater than. That means we're going to shade up. So imagine laying your pencil along this line and pulling it up. So we shade above that dashed line. Now, any points located in this shaded area are going to be part of our solution. Let's test some solutions. -3, 2, 3 left, 2 up, definitely in the shaded area. That's a solution. 0, 0, that's on our dashed line. Again, dashed lines mean that the points along those are not a solution. So 0, 0 is not a solution. Lastly, 2, 1 in the white area, not a solution. All right. When you shade these areas, you don't want to make it really solid where you can't see, because it'll be hard to find a point in your solution area if you do. Let's look at 2 more possibilities. We could have y is less than or equal to, or y is greater than or equal to. On a number line, these are, oh, that's not a letter. These are closed on a number line. In the land of coordinate grids and two variables, these are going to be solid lines. So anything with a line under it means solid line. We're going to graph these lines just the exact same way that we did above. We can imagine this as y equals x, and we graph the line that splits quadrants 1 and 3 in half. Again, this is less than. That means we shade below. So we're going to shade down here. Oh, look, I made a mistake already. This should have been a solid line. I just said that, and then I drew a dashed one. Sorry about that. Let's check our solutions. -3, 2, 3 left, 2 up. That's in the white zone. Still not a solution. 0, 0. Now 0, 0 is on the line. That means we can consider it a solution. And then 2, 1, 2 right, 1 up. Again, that's in the shaded area. That's also a solution. Let's do the same thing for y is greater than or equal to x. We're going to graph this same line. Again, it's solid. I'm going to get it right the first time this time. With greater than, though, we're going to be shading above the line. So I'm going to shade up here. Let's check our points for solutions. -3, 2. 1, 2, 3 left, 2 up. That is in the shaded area. That is definitely a solution. 0, 0 right here. It is also on the line. It is a solution. Lastly, 2, 1. That is not on our line or in the shaded zone. That is not a solution. Those are the basics behind graphing these inequalities in two variables. We're going to do a little bit more exciting lines and see what we can figure out. So we're going to graph the lines, and then we're going to circle whatever solutions we have that are true. Actually, we're going to have to circle so many that we're going to just mark through the ones that are not true. How about? All right, let's do it. Y is less than 3x minus 2. You can, as always, use the make a table method for graphing these lines. I'm going to use all the shortcuts I know because this is hard enough as it is. Our y-intercept is -2. This is b, remember. So we'll go down 2 to get started. Then the slope is +3. That's m. So from this red point, we're going to go up 3, right 1. Up 3, right 1. Or down 3, left 1. Same idea. Now, let's look. We've got some points plotted. Let's look at our inequality. Is this going to be a dashed or a solid line? This is a dashed line. So we'll dash this line. And there we go. We've got that so far. Last step of graphing this is we have to shade the solution area. So it's less than. I'm going to lay my proverbial pencil along this line and pull down. That means I'm going to shade this part of the graph. So we shade over here. Let's check for solutions. -3, 2 is here, not a solution. 0, 0, not a solution. 1, 4, not a solution. 2, -5 is a solution, so we can just circle that guy. 0, -2 is not a solution. It's on our line. This is a dashed line, so that doesn't count. -4, -2, not in the solution zone. 2, 2 is definitely shaded. -2, 3. Ooh, -2, 3 is not. And 3, 0 is in the shaded section. All right, let's try it again. 1 down. Y is less than negative 2/3 x plus 4. Again, this is our y-intercept, so I'm going to go up 4. And the slope is negative 2/3. So down 2, right 3. This is going to be a dashed line because there's no equals in our inequality. And it's less than, so I'm going to shade below. It's over here. So far, so good. Let's test some points. Negative 3, 2 is shaded. 0, 0 is shaded. 1, 4, not in our solution area. You should really pause here and check these out on your own and then double check with me. 2, negative 5 is shaded. 0, negative 2 is shaded. Negative 4, negative 2 is shaded. 2, 2, yes. Negative 2, 3, yes. 3, 0, yes. So the only one we don't have to shade is 1, 4. All right, let's do it some more. Y is greater than negative 4. Remember, we're going to make a table of values. Negative 4 is the answer all the time, no matter what x is. So I just go down to negative 4, and I'm going to have a dashed horizontal line at y is negative 4. The inequality sign is greater than, so we're going to shade above negative 4. Let's test some points. You should definitely pause here and see which of these points lies in the solution area. Negative 3, 2 is yes. 0, 0 is yes. 1, 4 is yes. 2, negative 5 is no. 0, negative 2 is yes. Negative 4, negative 2 is yes. 2, 2, negative 2, 3, and 3, 0. Those are all yeses. Just one no that time. Okay, so far so good. Let's look at a little bit different ones. We've got 2x plus 3y is less than or equal to 6. This is set in standard form, so I'm going to check for the intercepts. I can say 2x, not that, is equal to 6. That means x is 3 as my x-intercept. I can also say that 3y equals 6, or y is 2 as the y-intercept. Now, this is got an equals in the inequality, so this will be a solid line, and it's a little less than, so we're going to shade below. So down here. Let's check our solutions. Pause, try to check your own. Negative 3, 2 is a solution, so 0, 0. 1, 4 is not. 2, negative 5 is 0, negative 2 is negative 4, negative 2. 2, 2 is not. Negative 2, 3 is a solution. And 3, 0 is a solution. It lies along our line. All right, that'll do it. Next one. Y is greater than or equal to 3/2 x minus 1. This again, that's not what I wanted. The negative 1 is our y-intercept. So we'll start down 1. And then the slope's 3 over 2. So 3 up, 2 right. I'm going to do it one more time just for safekeeping, and maybe 3 down and 2 left as well. This is a solid line because of the equals in the inequality. And it's greater than, so I'm going to shade above. Let's check our solutions for ones that are correct. Negative 3, 2 is, so 0, 0. 1, 4 is a solution. 2, negative 5 is not. 0, negative 2 is not. Negative 4, negative 2 is. 2, 2 is on the line, and it's a solution. Negative 2, 3 is. 3, 0 is not. All right, last graph. Let's see what we can do. X is greater than or equal to -2. Well, again, we can imagine a table. X can be whatever we want. Y is always, or X is going to be -2. Y is whatever we want. So we're going to go to X is -2 and draw a solid vertical line. Imagine we're on a number line. Are the points that are greater than -2 to the right or to the left? You're correct. They're to the right. So we're going to shade to the right. Let's check our solutions. -3, 2 is not. 0, 0 is. 1, 4 is. 2, -5 is. 0, -2 is. -4, -2 is not. 2, 2 is. -2, 3 is. 3, 0 is as well. So that's pretty much all there is to it. It's just graphing using the correct type of line and the correct shade. You can totally do it. It's got a lot of steps, but I know you can do it. Let me know if you have any questions, and I hope to see you soon.